everyone, our topic is regarding related rate melting snowball. Related rate is an application of differentiation can help us solve many types of real-world problems. One of the example of the application of differentiation in related rate, it is where two variables are changing over time. Between these variables, there is a relationship. What we will discuss here is not the relation between the variables themselves. Instead, we will describe a relationship between the rates that come out. The rate of change is usually with respect to time. Differentiation with respect to time or one of the other variables require replication of the chain rule because most problems involve several variables. Fundamentally, if a function f is defined such that f equal to fx, then the derivative of the function f can be taken with respect to another variable. We assume x is a function of t, so x equal to gt, then f equal to fgt, so overall it's going to be like this one. Then we're going to write it in a Leibniz notation, that is df over dt equal to df over dx multiply dx over dt.
A snowball was made from two spherical snowballs. Smaller snowball A is on the top of the bigger snowball B. As the sun is shining, the snowman begins to melt where the surface area of both snowball A and snowball B are decreasing at the rate of 3 cm square per minute and 5 cm square per minute respectively. Question 1. How fast the radius is changing for snowball A when the diameter is 30 cm? Given that A is equal to 4 pi r square. Question 2. How fast is the volume R changing for snowball B when the radius is 30 cm? Given that A is equal to 4 pi r square and V is equal to 4 per 3 pi r cubed.
Let's take a look at solution number 1. First of all, we must find the radius. Given diameter is equal to 30 cm, so r is equal to 15 cm. This is a solution for question 1. It is given that a equal to 4 pi r square. We can substitute the value of a in equation of derivative of a with respect of t. Now, we can bring the constant to the front. We'll end up with 4 pi multiplied with derivative of r square with respect of t. Multiply 4 pi and 2r and we get 8 pi r dr over dt. Next, substitute the value of dA over dt and r into the equation. Therefore, we got the answer for dr over dt, which is negative 1 over 40 pi centimeter per minute. Let's proceed to solution number 2. Given that r is equal to 30 centimeter. For question 2, the first step, it is similar to the question number 1. Substitute the value of a into the equation, derivative of a with respect to t. Bring 4 pi to the front and we end up with 4 pi multiplied with derivative of r square with respect of t. Apply the chain rule to the derivative of r square with respect of t. After simplify, we get 8 pi r dr over dt. Substitute dA over dt and r into equation and we get negative 1 over 48 pi centimeter per minute. Now the second part of equation number 2. Given the value of V is equal to 4 over 3 pi r cubed, put it into an equation. Bring the constant 4 over 3 pi to the front and multiply it with derivative of r cubed with respect of t. Simplify the equation and we will get 4 pi r squared dr over dt. Then substitute the value of r and dr over dt into the equation. Therefore, we will end up with dv over dt equal to negative 75 centimeter cubic per minute.
In conclusion, the solution we used to find the rates of changing radius and volume of the two snowballs with different diameters is success. When the snowball is melting, the radius is at the rate of negative 1 over 45 cm squared over mean, and the radius is 15 cm. The negative value testifies to the radius is decreasing as the snowball melts. Besides that, the volume is decreasing around 75 cm³ over mean. That's the answer.
Created using Powtoon.